In the last video, we were just looking at the black hole at the center of our own Milky Way galaxy and how they detected it. Well, they knew it was a black hole only because they looked at the orbits of stars around it, and these stars were orbiting some invisible object there, and from there they could figure out the mass of the object, which we just calculated. So we just did like what the scientists did here. So it turns out they found the mass was 4.1 million solar masses. By the way, if you're wondering how correct is this, how close is this to accepted value, the accepted value is right around 4.1 million solar masses. So again, our method, by sort of being a bit dodgy and assuming circular orbits and using this equation, gets us very, very close to the correct answer, which I think is really, really interesting. So we can do things very close to real science just by using our basic laws of physics here. And then, of course, then they were able to figure out, well, it has 4 million solar masses, but it's in such a small area here, such a small region. The only thing that could explain it is something that we call a black hole, something that has a very, very small density. A very large density, a very small sort of volume, you could say, because density is mass over volume. So large mass in a small volume has a large density. So the black holes that we look at, it turns out they're found at the center of most galaxies. Now that, I think, is a really, really interesting fact. So that turns out that almost every galaxy that we look at, no matter what you're, pointing your telescope at, it turns out you end up seeing galaxies in the center. So this is actually really cool here. So the question is then, do black holes cause galaxies? In other words, do you have to start with a black hole and then do those cause galaxies? Or do galaxies cause black holes? In other words, if you have a galaxy, do you then get a black hole? In other words, which comes first? It's like this, we say, which came first, the chicken or the egg? So do black holes cause galaxies? Do galaxies cause black holes? These are questions we still have to look at and answer in science. We don't really know. Do they form together? It seems like it. So these are some of the sort of questions here. So no matter what we're looking at, we can look at all sorts of crazy other galaxies that we look at. They don't have to all be spiral either. But let's just say it's a spiral galaxy. If we look carefully at the center, we find black holes all over the place here. All over the place in that almost any galaxy you look at carefully seems like it has a black hole in the center. Some galaxies have multiple black holes in the center. That's pretty interesting too. So for example, this is a little bit like, two kids at a playground who are sort of holding hands and spinning around. If you imagine a black hole here and a black hole here, and they're orbiting each other, these black holes. Now it's at the center of a galaxy. Now they think, so this is thought to be, maybe it's actually two merging galaxies. So maybe you have one galaxy that's actually been sort of running into the other one. So all the mass in the galaxies are sort of spinning around each other. And they haven't quite reached an equilibrium. They haven't quite reached, what we would say is, their sort of final state. Which means maybe there's one galaxy with one black hole that's meeting up with another galaxy with its own black hole. Oops, I'm trying to draw a spiral here. I'm not doing a very good job. But see, these two sort of mixed around and started sort of, orbiting around each other. As they get closer and closer to each other, the black holes will also get closer and closer to each other. So they think it's two merging, whoops, I can't seem to spell here, two merging galaxies. So they think then that really, really super duper massive galaxies, then the reason why their black holes are even bigger is because they think that these black holes eventually sort of merge together. Or maybe more than two, maybe there's a whole bunch. Now we can of course go to the next thing right here. A lot of people think that a black hole sucks everything in. Sometimes you've seen these sort of three-dimensional graphics here, and I'm going to try to draw this, but it's really hard to draw here because I'm not a very good artist for starters here. But you could sort of draw these sort of lines going in like this here. So a lot of people sort of assume that, everything around it, no matter where you are, you get sucked directly into this sort of, black hole here, into nothingness, or who knows where they go. People talk about, is it a wormhole? Can it get you somewhere else? That's very difficult to answer because it's hard to actually go there. First of all, they're very far away. But second of all, it turns out from what we know about physics, you do not want to enter a black hole. Now it turns out that stars, for example, can be in happy orbits. What I mean by happy is, a stable. So stars can be in happy orbits around them. So things don't all go in. And what if you're a star over here and you can just orbit around all the time? No problem. I mean, that's a happy orbit, right? No problem there. And it won't eventually go in necessarily. It'll just orbit around for a long, long time. Just like we see going on in the center of our own galaxy. Right? The center of the Milky Way, there's a whole bunch of stars that are in happy orbits around this point. They're not all going directly in. So that's one thing I think that's interesting about black holes. It's not that everything gets sucked in, but that being said, you do not want to be within a certain radius. So, the sort of a little, note. Stay out of the, what we call the event horizon. So we have this thing that's called, it turns out, it's called the Schwarzschild radius. We actually write as RC. And depending on the mass of your black hole, you can calculate what this radius is. But this is a radius, so this is where, so what this means is where nothing can escape. So that means that if you do come too close, so I mean, although you can be outside of a black hole and be in a happy orbit, there is sort of a magical sort of radius. Let's just say it's here. Let's just say that was the green one right there. There is that radius where you do not want to cross it. Okay, so where nothing can escape, not even light. That's because the escape velocity, in physics we can talk about how fast you have to go to escape an object. For example, on Earth you can calculate the escape velocity. You have to go a certain speed to escape the Earth completely. Well, it turns out there exists a certain radius, around a black hole, at which the escape velocity, or anything there or inside, escape velocity is c. In other words, speed of light. So that means not even light can escape, which means if you go within that radius, you're never coming out. No matter how fast your ship can go, even if your ship goes the speed of light, you're still never going to escape. In other words, if you shine a flashlight out here, it'll go sort of up and it'll go actually back in. So there is sort of this thing that, you do want to note that do not go within this Schwarzschild radius here. Do not go within there, because within that, then you are in trouble. But anything outside of that, let's say you have a star that's on the outside, it can be a nice happy orbit for millions and millions of years. No problem.